Hey guys, welcome back to virtual learning. That means that instead of watching me go through this stuff in class, and instead of seeing me and all that good stuff, you get to listen to me through Edpuzzles. So, well, today is not an Edpuzzle, but after today, lessons will be Edpuzzles. I'll do my best with my pencil not to tap really obnoxiously, but that happens sometimes. So no promises, but I'll do what I can to be a little bit quieter. Okay, looking at today, we're looking at lesson 7.4, which, if you remember all the way back to Thursday, we took the quiz on Thursday, and then we took the second half of class to break into groups and break up some of these corollaries and terms and things, and then to present them. We only got through the first three groups, which was awesome, but unfortunately, the second three groups will not be able to present. So sorry, I think that was the entire back row. Sorry guys, you will not be able to present, and we're just going to have to get the information this way. So I'm going to recap what we talked about with those first three groups and build off that to look at what the next three groups would have pointed out, and then that is it for today. So 7.4, properties of special parallelograms. If you remember, the first group introduced to us that we are going to be looking at three different types of parallelograms: a rhombus, a rectangle, and squares. A rhombus is defined because it has four congruent sides, and the classic rhombus shape is that with those slanted sides, and then the tick marks to show that we have four congruent sides. A rectangle is a parallelogram with four right angles. So it doesn't say anything about the sides, but just that we have four right angles, and a square is a combination of them both, right? Of four congruent sides and four right angles. So we're going to define rhombus a little bit more. A rhombus is a quadrilateral, a quadrilateral is a rhombus if and only if it has four congruent sides. Okay, so repeating what we talked about earlier, it has to have those four congruent sides. A rectangle is a quadrilateral if and only if it has four right angles. Again, taking that definition of a rectangle and putting it into a corollary and relating all of these to saying they are quadrilateral, or a shape that has four sides. And a quadrilateral is a square if and only if it is a rhombus and a rectangle. Now this time it's a little bit different, right? It doesn't say a square is a quadrilateral if and only if it has four congruent sides and four congruent angles, but it just says that a quadrilateral is a square if it is a rhombus, so having four congruent sides, and a rectangle, so those four congruent angles. So the wording is a little bit different there, but it means the same thing. Then we looked at this example, and the last group did a really nice job of that. So it says for any rhombus, Q R, whoa. There we go. That looks pretty good. Q R S T. Remember, in a rhombus, that means that these are congruent. That means that these are congruent. For any rhombus, decide whether the statement is always or sometimes true. Draw a diagram to explain your reasoning. So in a rhombus, is it always or sometimes true that Q, I'll change colors, Q is congruent to S? Well, that would be always true because they are diagonals, and we looked at quadrilaterals and parallelograms that those diagonals are always congruent. Q is Q always sometimes congruent to R. Oh, whoops, I put those congruent angles in the rhombus, which isn't always the case, but it could be the case because a square is a rhombus. Whoops. Nope. I hope you guys see what mistake I made in drawing that rhombus. In a rhombus, those... There we go. Well, I guess those angles always are congruent, aren't they? Yeah, I guess those would be congruent. Look, it's just like class, where I make a mistake. But I could edit that out. But we'll see. Anyway, so those are always congruent, yes. Q and R would be sometimes congruent. And what they pointed out, that group pointed out, is that if we have a square, then they are congruent in that case. So those diagonals will always be congruent. Sometimes these angles that are right across from each other will be congruent as well. Now for this next one, we need to classify the special quadrilateral. So remember, the title of this lesson is Special Quadrilaterals, so that's what we're looking at. If this is 70, this side would also be 70, so that gives us a total of 140 degrees. Remember, all these have to add up to 360, excuse me. $220 is what we have left over. So that means that this side is 110 and this side is 110. So this would definitely then be a rhombus. All right, here's the new stuff. Theorem 711, rhombus diagonals theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So that should sound a little bit familiar dealing with the diagonals, because we have done that before. So again, you can see in this picture that we get the 90-degree angle formed by those diagonals. That's what it means to be perpendicular. So a rhombus, or a parallelogram, is a rhombus if and only if its diagonals are perpendicular. Theorem 712, rhombus opposite angles theorem. Rhombus, or that would be parallelogram, ABCD is a rhombus if and only if AC bisects BCD. So these diagonals not only are perpendicular to each other, but also bisect each of these angles. And sometimes people will look at like this one and say, look, this arc is wider than this arc. Well, the second arc is further in or closer to the angle, so it looks like one arc is bigger than another, but we have to look at what those tick marks are saying. So find the measures of the number of the numbered angles in rhombus ABC. It looks like I forgot to put the picture in. So let me see if I can find it. So here's what it looks like. It looks like this. And we have A, B, C, D. This and this says this is 61 degrees, and then this is angle 4, 1, 2, and 3. And we need to find each of them. So if we look at angle 1, well, we know that these angles have to be perpendicular, so that would have to be 90 degrees. Now, if we look at angle 2, well, let's look at angle C first. We know that this has to be congruent to this, so that has to be 61. We know that these diagonals, so A and C, have to be have to be congruent to each other. So that would tell us that 2 and 3 both need to be 61 degrees. And then angle 4, if we know that we have this whole side would be 122, then this other side, angle A, also needs to be 122. So we have 116 left over for those other sides. For B, oh, I wrote B twice. For D and B. So let's see, we need to do 116 divided by 2. Give us 58 for the total measure of angle D and total measure of angle B. And then to find specifically angle 4, we would need to split that in half, right? Because the diagonal bisects that angle. So 58 in half would give us 29 degrees. I think this will be our last theorem. 2 more examples. Quadrilateral ABCD is a rectangle if and only if AC is congruent to BD. So notice in a rectangle that, well, notice that these last couple theorems all deal with the diagonals, all right? That's where we're focusing these last few theorems. The first couple theorems dealt with a rhombus, right, and the diagonals in a rhombus. And then this one deals with the diagonals in a rectangle. Now it's important to remember that a square is a type of rhombus. So these would also be true for a square. With this theorem 713, rectangle diagonals theorem, a parallelogram is a rectangle if and only if its diagonals are congruent. So we can see the tick marks up here with the that's white, on the diagonals. So these diagonals need to be congruent, and then that's how we can know that we are dealing, or that's one way that we can know that we are dealing with a rectangle. So let's look at a real life, legit application you 100% will definitely use someday without a doubt. You are building a frame for a window. The window will be installed in the opening shown in the diagram. So here's going to be our nice window. It'll be a see-through. The opening must be a rectangle. Given the measures in the diagram, can you assume that this opening is a rectangle? Explain. Well, right away what we should see is that these opposite sides are the same. Right? That I mean, we can tell pretty quickly. So we're on the right track. We see that these opposite sides are the same as well. Now, with our definition of a rectangle, is that all that we need? Is that the opposite sides are the same? Let's see where our picture went. ABCD is a rectangle if and only if the angles are all right angles. Now, even though all those sides are the same, we cannot assume that we have right angles all here. Because think about it, in a rhombus, these side lengths are the same, but that doesn't mean that all these angles are the same. So this, technically, even though it looks like it's a rectangle, and it very well could be a rectangle, we cannot know for sure that it is a rectangle without seeing those angles. So there would be letter A. You measure the diagonals of the opening. The diagonals are 54.8 inches and 55.3 inches. What can you conclude about the opening of the shape? Well, now we can know the diagonals are different, right? That's the main thing. It doesn't matter if they're 0.5 off or whatever it is. The diagonals are different. So that means that we know for sure that no, this is not a rectangle, because that last theorem that we looked at said that the diagonals have to be congruent. So once we look at the diagonals, we know without a doubt for sure that those are not the same. Or we know that diagonals aren't the same, that's what they tell us, but we know that it's not a rectangle. Excuse me. Last question, example 5. And of course, you probably knew it was coming that we would deal with the coordinate plane. So it would be wrong if we didn't try to graph some stuff here. Decide whether ABCD with those vertices is a rectangle, rhombus, or a square. Give all the names that apply. So let's see, A is at -2. 6, 8, 1, 2, 3, 4, 5, 6, 8. C is at 0, 4. Oh, whoops, 4, 0, not 0, 4. And D is at -4. Now, right away, when we look at the coordinate plane, we know that we cannot determine what angle measures are. So we can't just look at this or do a couple things and see if that is a right angle or not. So when we are determining what shape this is, we need to be using the sides, and we know that that probably will come down to distance formula. So what we want to do when we look at a problem like this is we could find AB, BC, CD, and we could find all those side lengths, and that would tell us if AD is the same as CB and all that good stuff. But like we saw in the last example, that wouldn't necessarily tell us what shape this is, right? I mean, we can have sides that are all the same, but we don't know if it's a rhombus and a rectangle, or just a rhombus, or just or whatever it might be. So what we need to do is look at the lengths of the diagonals. So the first thing we would want to do is look at the length of AC and use the distance formula to find the length of AC. At this point, we've done the distance formula enough that I am not going to go through finding the distance formula or using the distance formula to find the length from A to C. So I would just tell you the length from A to C, what it all the way simplifies to is 6 square roots of 2. And the length of BD, this other diagonal, simplifies to 10 square roots of 2. So these are not congruent, are they? 6 square roots of 2 and 10 square roots of 2. So we know then that this definitely is not a rectangle. We know that for sure. Since it is not a rectangle, that means it cannot be a square either. So that takes rectangle and a square right off the table. Now, the last thing that we want to look at is if this could be a rhombus. Well, what did we learn about with the diagonals of a rhombus? We said that the diagonals need to be perpendicular. Well, that's something we could test for. We could see if they're perpendicular. We could look at the slopes. And the angles is not something that we can test for. So the last thing that we need to do to check to see if this is a rhombus or not would be to look at the slopes of those perpendicular lines. So if we look at the slope of AC, we would find that the slope is -1. If we look at the slope of BD, we would find that the slope is +1. Well, since we have those opposite slopes, then that means that we do have a rhombus. So hopefully, I mean, what we're trying to show here is if it gives you points and it tells you decide which shapes, give all the names of the shapes. We check to see if something is a square or a rectangle by looking to see if those diagonals are congruent. So that would be our first check. We can see if something is a rhombus by looking to see if those diagonals are perpendicular. That would be our second check. So hopefully that stuff that we talked about earlier was a good review and reminder of what we looked at on Thursday. And I know without a doubt that those last three groups would have nailed all this stuff in the second half of the lesson. And I'm sorry they don't get the opportunity to do that. But this is where we're at for today and for this week. So if you have any questions, make sure that you let me know. Otherwise, have a good day.